This is an introduction to basic matrix theory. This is what a matrix looks like. We have a series of numbers and rows and columns within brackets, and in just a minute I'll tell you what those numbers mean beside the A. Alright, matrices are going to be really useful for us, and in this chapter these are three big questions we want to be able to answer. How can large collections of data be organized and managed in an efficient way? What calculations provide meaningful information to people who use the data, and how can computers and calculators assist them? Matrices usually come into play when we have a lot of data and it's too much to do by hand, so it's easy to just store it in a matrix and we can do the math with the matrices, and that's what this chapter is all about. So here's a word problem, for example. So your friends are planning a pizza and video party. You decide to call several pizza houses to ask about prices for large single-topping pizzas, liter of cold drinks, and family-sized salads with house dressing. If you wanted to, you could record your information in a table if you had some very organized and nerdy friends. And you could also take that information and put it into a matrix. Okay, so the order or the dimension is 3 by 4. Notice that there are there are 1, 2, 3 rows, and there are 1, 2, 3, 4 columns. Okay, so we always refer to a matrix order or dimension as row by column. Each individual entry in the matrix is called an element or a component of that matrix. Okay, here's the slide again that we kind of breezed through a minute ago. We have matrix A, and we have this weird notation. We have lowercase a with some numbers beside it. Basically, the position of each element is going to be denoted by, and this isn't great syntax down here, I'll rewrite this. It's going to be A, and then we have row, column. So that doesn't, like, for example, this first component here, A11, that's not necessarily A11. It doesn't mean it's the 11th anything. It just means it's the first row and the first column. And for example, A22 is going to be the component in the second row and in the second column. And then depending on how many components you have, for example, how many columns you have, we could have this one A in the first row, but then in the nth column, depending on how many columns there are total. And by the end here, the words are kind of in the way. We're going to have what looks like A to the mn. So however many rows there are with however many columns there are, it's going to be the last element in that matrix. A couple special matrices. First we have a square matrix, and that's where the number of rows equals the number of columns. So notice that this one is 2 by 2. A column matrix is a matrix where the number of columns is 1. And notice the components within these matrices, they don't have to be these particular numbers like 1, 0, or 1, 2, 3. These are just examples. So yeah, notice we only have one column here. It doesn't matter how many rows there are to be a column matrix. We just have to have one column. And then the opposite scenario, if we have a row matrix, that's where the number of rows is just 1. So this is our row matrix here. Alright, our last two examples here are a zero matrix, matrix with all zeros, pretty straightforward. And then next we have the identity matrix, and this one's kind of interesting. It's a square matrix first of all, so rows and columns must be the same. And notice that there are ones along the main diagonal, and there are zeros everywhere else. Okay, and in our picture here, for example, look at I3. There are 3 ones along the diagonal, and zeros fill in everything else. For I1, there's just a 1 and no zeros, because there's no room for any zeros. And on the far right, looking at I sub n, it just depends on how many rows and columns we have. I mean, we can make it as much as we need to, depending on the type of problem we're given. So this may look kind of weird to you if you're seeing matrices for the very first time, but the identity matrix is actually really useful, especially when you do more applied mathematics or if you're taking like a linear algebra course. You see this come up a lot.